Hello ladies, and welcome to our first video. As you watch this video, using the worksheet that you got from your teacher, go through and fill out the worksheet as I talk to you. So this first video here is about the foundation of physics and Newton's first law, which is the law of inertia. Okay, so the first question we have to answer when we talk about physics is, what is it? Well, a basic definition of physics is that physics is a science that deals with matter, energy, and their interactions. So this is a pretty basic and fundamental definition of physics, but basically we're excited about the fact that stuff moves and we can study how that movement happens. This is important when we talk about things like space, atoms, how atoms fit together and build up mass and other things, and then things like dark energy and quantum mechanics and relativity. Physics can get really, really complicated, but the physics that we're going to be talking about mostly is how stuff moves. So, physics is really old. It's one of the oldest sciences there is. It was founded by this guy called Aristotle, who was living in ancient Greece from 384 to 322 BCE. Why Aristotle was so important is that he really made the first observations about matter in motion. This is a really big deal in the history of science. So he kind of got the ball rolling. Balls roll, it's a physics joke. Anyway, our next important guy is this guy called Galileo Galilei, who I'm sure you've probably heard of in your history class. He lived from 1564 to 1642 in Italy. Why he was such a big deal is he did a bunch of really, really important and cool experiments, like he dropped a bunch of balls off the Leaning Tower of Pisa. Now, he was the first one to really explain how gravity worked, and how gravity worked correctly. A lot of people had all sorts of ideas about gravity, but he was the one who officially got it right. And, spoiler alert, he was also responsible for explaining something called inertia, which we'll get to in just a second. Our most important old dead guy, however, is this guy called Sir Isaac Newton. He lived from 1642 to 1727 in England. He was awfully helpful to physics, so very important, because he came up with these things called Newton's three laws. He wrote the most important book ever written in science, which is called The Mathematic Principles of the Natural World, simply abbreviated by most people as a book called Principia. This book laid down the three laws that govern how the universe worked, and we're going to talk about those this semester. But he also had this really important thing that he invented, calculus. You might have heard of calculus before. It's a type of advanced mathematics. But all in all, Sir Isaac Newton is a really important guy who got us going. So, you've probably heard the story of how the apple fell on his head and how that's how he invented the idea of gravity. Modern physics historians aren't entirely sure if that's what actually happened, but at least it's a good story, right? Okay, so, starting with Physics 101. Let's just observe this video here of this ball rolling. Okay, you got that? Now let's look at another video of a ball rolling. Okay. What was the difference between the first ball and the second ball? Well, I'm sure you could tell. Ball 1, based upon the measurements and the time, it took 3 seconds for that ball to cover a distance of 30 centimeters or 0.3 meters. Now, ball 2 took 1 second to cover the same distance. What can we say about this? Well, ball 2 had a greater speed. Let's talk about what speed is. Speed is a rate of motion. Okay, that means that there are two measurements that go into speed. The first thing that goes in is distance, how far an object traveled. The second thing is time, how long did it take it to travel that distance. So we get the speed formula. Speed is equal to distance divided by time. Now, you've probably heard of this before in things like miles per hour or kilometers per second or meters per second. These are all common units of speed. Now, the one that we're going to focus on, and the one that physicists like to use so much, is meters per second. So 9 times out of 10, when we do a speed problem, we are going to be using meters per second. Okay, so let's calculate the speed of the balls. So, the first ball, the speed it traveled is equal to the distance that it went, 0.3 meters, over the time that it did it, which is 3 seconds. So 0.3 divided by 3 equals 0.1 meters per second. See how this meters per second sticks with my final answer? Just like how we made you use units for things like mass and volume, you have to use units for speed. Speed, however, comes with 2 units, the distance and the time. So when I ask you to give me the speed of something, make sure you have those 2 units that go with it, meters per second. So the speed of the first ball was 0.1 meters per second. Now the speed of the second ball, distance over time, so 3 meters over 1 second. So the speed of the second ball is 0.3 divided by 1, which is 0.3 meters per second. So which ball moved at a faster rate? Well, that would be the ball with the faster speed, ball 2. Therefore, ball 2 is moving at a faster rate. Okay, now let's observe this. Okay, what just happened here? Why didn't the salt shaker fall over when I pulled the transparency out from under it? What do you think would happen if I pull the transparency a little bit more slowly? Let's take a look. Okay, think about that for a second. Let me give you some ideas. This is very important. Newton's first law, he says that any object moving will continue to move in a straight line with a constant or non-changing speed unless there's something that acts against it that causes it to slow down or to stop. Now, conversely, any object not moving will continue to not move unless something acts on it to make it move. Okay, what does that mean? So, this is defined as inertia. Inertia is a property of an object. Every object has this property of inertia. And each object's inertia is the object's ability to resist change in motion. Inertia is always equal to an object's mass. So the more massive an object is, the greater its inertia. Now, what's mass? Mass is not the same thing as weight. That's one of the most important things I can communicate to you. And this is something that we like to use the words interchangeably, weight and mass, as we talk to each other in everyday talk. However, they're not the same thing. Mass is a way to measure inertia using numbers, and we like to use kilograms in the metric system. Now, mass is how much matter is in an object. Mass is constant. Weight is the measure of how much gravity pulls on an object's mass. That's measured in the metric system in newtons, which are abbreviated capital N. Weight changes. Weight can change depending upon how much gravity is pulling on an object. So for example, on Earth, you weigh a certain amount. When you go to the moon, your weight will decrease because the moon doesn't pull on you as much as the Earth does. Therefore, if you were to stand on a scale on the moon, your weight would be less. However, your mass hasn't changed. You will still look the same, but your weight will be less. Your mass is constant, your weight is not. Does that kind of make sense? All right, so revisiting the example we have here and remembering Newton's first law, what happened here? When I pulled on the salt transparency the first time, I pulled so fast that there wasn't enough time to overcome the inertia of the salt shaker. I only overcame the inertia of the transparency. Because the salt shaker has much more mass and has a greater inertia, I would need to pull a lot more to make the salt shaker come with it. So let's think about the second time. By pulling slowly, I was able to overcome the inertia of not only the transparency, but the salt shaker too, which caused it to move. It was initially very happy to just be sitting there, but when I pulled slowly, I pulled not only the inertia of the transparency, but also the inertia of the salt shaker, so they both tipped over. Okay, so here's another good example of Newton's first law. Have you ever been riding your bike and you ran into a curb or something like that? Your bike stopped moving, but you didn't. Your inertia wanted to keep you moving in the same direction at the same speed. So that's when you see people go flying over the handlebars of bikes. It's Newton's first law. You will remain in motion at the same speed in the same direction, even though your bike came to a screeching halt. And that's why you get projected over handlebars. Okay, so that's our first video. So make sure you've filled out your worksheet and you've gotten all your definitions written down, and then answer the questions. And if there's any questions that have come up while you are watching this video, make sure to note them at the bottom of your worksheet. Awesome. Thanks, ladies.